Sensor Switch Controls Product Overview. The information in this presentation is confidential and proprietary and may not be used, reproduced, or distributed without the express written permission of Acuity Brands Lighting Incorporated. The topics for this module include Sensor Switch and Acuity Brands, Sensor Technology Review, Sensor Selection, and Sensor Switch Support and Tools. Sensor Switch and Acuity Brands. Acuity Controls is advanced lighting controls technology, service, and support from a single expert source. We offer one of the industry's most extensive product portfolios for indoor and outdoor applications, single rooms to campuses to municipalities. Our product solutions include occupancy and photosensors, panels, switches, fixture level, and wireless controls. It's not just smarter, it's easier. So, why sensor switch lighting controls? Code compliance. Lighting controls are being mandated by many codes and standards being adopted across the globe. Depending on local code and the judgment of the authority having jurisdiction in your market, lighting controls may be required in new construction and renovations for both interior and exterior applications. Energy savings. The sensor switch offering of occupancy and daylight sensors are designed to optimize energy savings and enable sustainability. Our broad product offering provides solutions for applications requiring energy code compliance. Using innovative detection technologies that maximize energy savings, we save you more. Reliable performance. Sensor Switch is a leader in lighting control innovation, continuously developing technologies to enhance performance of our occupancy sensors and photocells, providing trusted quality and reliability. We offer a broad selection of occupancy and daylight sensors to meet every application. Ease of installation. Sensor Switch products are easy to install due to our patented features: reversible line and load wires, miswire protection, simple push-button programming, and our convertible neutral for wall switches. These powerful features save installation time and eliminate extra costs on the job site. Our comprehensive Sensor Switch Lighting Controls product catalog is the best source for all things sensor switch, product descriptions and ordering information, detector coverage pattern diagrams, wiring schematics, and more. The Encyclopedia of Sensor Switch, or Sensorpedia, is a guide intended to assist users in identifying the nomenclature used to choose the appropriate sensor switch sensor for your space and application. Each character or group of characters in a sensor switch model number indicates a specific feature or option for that particular sensor. The sections of this guide describe the choices available for each of the feature categories. By dividing up any sensor switch sensor model number into the parts described in this guide, the sensor's full functionality can be determined. This guide will also better enable you to build your own model numbers by choosing from each category the features and options your project requires. We will reference the guide throughout this presentation. You can view or download a copy of the Sensor Switch Lighting Controls product catalog at acuitybrands.com or by clicking the Resources tab in the upper left corner of this module. Sensor Technologies. PIR, or Passive Infrared Sensors, detect changes in the infrared energy given off by occupants as they move within the field of view of the sensor. The sensor detects the heat given off by the human body as it moves in and out of the sensor segment's view and triggers the occupancy mode. The sensors are fine-tuned to detect small motions even at great distances, while still preventing false-on conditions. All sensor switch sensors have PIR technology, while different segmented lens styles dictate the passive infrared sensor's coverage pattern. This technology is passive in that it does not generate or radiate energy for detection purposes. They function by detecting the energy given off by other objects and only generate an electrical signal when infrared energy is detected moving from one segment of the sensor to another. Passive infrared sensors are often combined with a second technology to make occupancy sensing suitable for more space types than infrared alone. Employing dual technology sensors can overcome the line of sight requirement of passive infrared devices. Most sensor manufacturers of dual technology devices employ ultrasonic technology in conjunction with passive infrared technology to see around obstacles. Ultrasonic occupancy sensors operate using the Doppler principle. They transmit ultrasonic energy through the space, which reflects off of all of the surfaces and room objects and returns to the sensor. The sensor measures the return frequency of the reflected energy and establishes an acoustic signature for the empty space. When an occupant walks into the room, the return frequency changes. The change between the empty room condition and the occupied room condition is determined, and if above a predetermined magnitude, it is processed as motion. Ultrasonic sensors operate at frequencies higher than the normal human ear can detect to avoid possible incompatibility with other devices, such as hearing aids. Ultrasonic sensors do not require a direct line of sight to operate, so they are generally employed in areas with obstructions. Ultrasonic sensors are active sensor devices. They are always transmitting a signal and looking for disruption in that signal. Active transmission of this signal consumes energy at all times. These devices are also more prone than PIR devices to false-on activity, as motion in adjacent spaces, air turbulence near air diffusers and open windows, vibration from HVAC systems, and hanging objects in the space can be interpreted by the device as human movement, turning lights on when there is no one in the space. Sensor Switch by Acuity Brands does not employ ultrasonic technology in any of its sensor products. Sensor Switch employs a patented advanced detection technology called Microphonics in common applications that have obstructions, such as bathrooms with stalls and open office cubicle areas. This detection technology uses a microphone inside of the sensor to hear sounds indicating occupancy. Unlike active dual technology described previously as PIR plus ultrasonic technology, this system is referred to as having passive dual technology, or PDT, as it does not consume energy to detect the audio input as ultrasonic does to detect frequency shifts. Microphonics is never deployed as a standalone technology. It is always combined with passive infrared. Occupant motion must initially be seen by the passive infrared to turn the lights on, after which occupants can either be seen via PIR or heard via Microphonics for the lights to remain on. It's important to note here that Microphonics has no provisions, either out of the box or with modifications, to record sound. Privacy is maintained as the sensor merely detects sound and reacts to it. But how does the sensor know what sound indicates occupancy? Microphonics only detects leading-edge noises typical of human activity, such as typing, talking, rustling papers, and so on. It filters out building noises like HVAC rumbles or airflow noises, as well as constant periodic noises like a ticking clock. Automatic gain control techniques are used to dynamically self-adapt a sensor to its environment by filtering out constant background noise. Advanced digital acoustic filtering prevents the prolonged presence of varying noises without any PIR events, such as leaving a television or radio on, from keeping the lights on. With only one exception, Microphonics never turns the lights on. In a dual technology system, the PIR sensor turns the lights on, and Microphonics keeps the lights on. In the event that no motion and no sound are created in the space for a prolonged period of time, The microphone is left on for a 10-second grace period after the lights are turned off to allow for voice reactivation. On-off photo control and dimming sensors provide intelligent control of lighting both indoors and outdoors, either standalone or in conjunction with occupancy sensing. All photo controls have an automatic set point calibration mode regardless of time of day or daylight conditions, improving reliability and reducing installation and setup time. The dimming photo control functions by comparing the amount of daylight available with a defined acceptable light level called the set point. The sensor can find its optimum set point via the automatic set point programming mode. In this mode, the sensor takes light readings at full bright and full dim in order to determine how much artificial light it is controlling. It then sets the minimum light level to be equal to this amount. It is assumed that the space is adequately lit by design. However, if this is not the case, the set point may be easily adjusted to the occupant's preferences. All modes and settings are entered digitally via a push-button sequence. Once programmed, the exact value of the set point in foot candles can be read out from the sensor via a series of LED flashes. Sensor selection. Studies have shown the significant energy savings available through the use of occupancy sensors, as we see in this breakdown of commercial space types and their fractional contribution to the overall built commercial environment. Space types show a greater or lesser degree of available savings, but the total energy savings in all commercial spaces combined is estimated to be 20 to 28%. When we break this down further to a space-by-space analysis, we can clearly identify the big winners. Those spaces in commercial facilities that are intermittently occupied have the largest potential energy savings. Restroom, 60%. Conference rooms, 50%. Private offices, 39%. Break rooms, 29%. And classrooms, 58%. Controlling the light helps building owners put money back into their own pockets. What about daylight harvesting? Daylight harvesting is the practice of lowering the contribution of electric lighting in response to the natural light available in the space. The intended practice of daylight harvesting has changed the way buildings are being designed and constructed, with greater emphasis on bringing natural light into interior spaces, not only to save energy, but to provide a more comfortable environment in the places that people live, work, and play. Dependent upon the building and the space type, energy savings from daylight harvesting can reach almost 50%. Some of the most popular sensor switch products include the WSXD dimming occupancy wall switch, the SPOD MRD dimming switch pod, the LSXR, a fixture-mounted sensor with interchangeable lenses, and the CMR series ceiling mount sensors. Let's go back to the Encyclopedia of Sensor Switch to see how to put the part number together to select the appropriate sensor for your application. The product model numbers provide details on the particular product, such as mounting type, power information, lens type, etc. Understanding the product naming convention will help you select the product that is correct for your application. In this example, we will show you the categories that make up the model number CMR PDT10P. First, we'll begin with the enclosures. The CM in this example stands for ceiling mount. Sensor switch sensors come in a variety of different enclosure styles that are both functional and attractive, while still being easy to install. The enclosure style for most sensors is indicated by the first few letters in their model number. Enclosures are available as wall switches, ceiling mounts, fixture or pole mount, snap fits, or embedded. There are even options for wet locations or wireless applications. The next category specifies how a sensor is powered, as well as its switching capabilities. By default, sensors are powered by low voltage and require a power pack to switch a circuit. Therefore, no special characters need to be added to the model number. In contrast, line voltage sensors are powered and can switch line voltage without a power pack. Line voltage model numbers have the letter R inserted with the enclosure designation, for example, CMR. Let's review the power types available with sensor switch sensors. Line voltage is indicated by the letter R in the catalog number. Sensors contain line voltage switching relays. They're ideal for retrofit applications with concrete or inaccessible ceilings. Sensor switch patented impossible to wire backwards interchangeable line and load wires. Sensors capable of switching two poles independently are indicated by adding 2P to the model number. Sensors capable of simultaneously switching two phases are indicated by adding 208 or 480 to the model number. Low voltage power supply is indicated with LV in the catalog number. These are powered via a power pack or other low voltage power source. When used with a power pack, the sensor is enabled for a complete 20 amp circuit to be switched. Enables multiple sensors to be used together to cover a larger space. It allows sensor mounting without a junction box and utilizes convenient low-voltage wiring techniques. Finally, wireless and battery-operated sensors. Wireless sensors are powered by a lithium battery. These are ideal for renovation applications that are difficult to wire through the walls. 10-year battery life at default sensor settings. Each unit uses a AA lithium 1.5 volt battery. Wireless sensors are paired with and communicate to wireless wall switches. This next section of the catalog number specifies the detection technologies employed by sensor switch. As we discussed in the technology review, sensor switch employs two types of detection technologies for occupancy: passive infrared and microphonics. All sensors use passive infrared technology by default. Microphonics is always paired with passive infrared to create passive dual technology. With passive infrared technology, sensors detect changes in the infrared energy given off by occupants as they move within the field of view of the sensor. PDT, or passive dual technology, is the combination of two detection technologies, PIR and microphonics. The sensor will first see motion using passive infrared and then engages the microphonics technology to hear sounds that indicate continued occupancy. The next portion of the naming convention is the lens type for the passive infrared portion of the detector. It's important to select a lens type with a PIR coverage pattern that accommodates the space's area requirements and also its application. The lens type options take into account the type of motion detected. It also lists the coverage pattern, the coverage range, and suggests what height this sensor should be mounted. Some of the lens options include wall switch lenses, large area wall switch and large area high mount wall switch lenses, high bay 360 degree and mini low bay 360 degree lenses, small motion standard range 360 degree and large motion extended range 360 degree lenses, bidirectional hallway lens and end of hallway lens, wide view 120 degree lens and universal 360 degree lens, high bay bidirectional aisleway lenses. The previous sections of this guide define the portion of the model number referred to as a sensor's series number. Following this series number, there may be additional characters in the model number that define the optional features included on the sensor. This section describes each option and its model number character suffix. The datasheet for each sensor series lists its available options. These additional options, including various types of dimming and zone control, ensure that the space is controlled specifically to your needs. Do you want the lights to turn off when no one is present? Or would you prefer that they dim to a lower light level? Or maybe you have fluorescent fixtures wired in tandem, and you would like to control the A/B switched light levels based on occupancy. These options are selectable by adding the appropriate suffix to the catalog number you have constructed. One of the key selections to be made when constructing a lighting control part number is whether or not the sensor should include a photosensor to take advantage of daylight harvesting opportunities. It is oftentimes convenient to integrate these detection methodologies in the same device to save on material and installation costs. Adding a photosensor to an occupancy sensor not only allows for greater energy savings, it helps to maintain light levels within the parameters dictated by the space type. In an open office space, for example, the electric lights may be designed to provide 50-foot candles at the desktop, but during the day, with light entering the office windows, the light levels may rise uncomfortably. In this instance, the combination occupancy daylight harvesting device will reduce the output of the electric lights when daylight is present and occupancy is detected, and reduce the output even further, or turn the lights off if daylight is present and occupancy is not detected. Combining the sensing of natural light and occupancy detection is becoming more common in exterior applications as well. Pole mount luminaires may be required by code to turn off or dim significantly during periods when the presence of people is not anticipated, like in a store parking lot after closing hours. However, if motion is detected during those hours when natural light is not present, the luminaire can be brought up to full brightness for safety and security. There are other times, however, where occupancy detection may not be required or is being handled by another device, and you just need a photosensor. Sensor Switch offers a comprehensive selection of photosensing devices used for daylight harvesting via switching or dimming. With our long history of product innovation, our best ideas have resulted in solutions to frustrations big and small. Some of these solutions include miswire protection. Sensor Switch developed reversible line and load connections, resulting in products that are impossible to wire backwards. This patented feature eliminates potential job site delays due to miswiring. Another Sensor Switch innovation, the convertible neutral wall switch. This is patent-pending technology that allows a sensor switch wall switch occupancy sensor in the WSX and WSD product families to convert from a no neutral connection to a neutral plus ground connection in seconds. If your application requires the use of a neutral connection, simply remove the ground link and wire per code, making installation quick and easy. This reduces job site frustration for the installer and allows for fewer SKUs on the service truck and the distributor's shelves. One sensor does it all. Support and tools. Available support materials include the Acuity brand's webpage, where you can find more information on the multitude of Sensor Switch products. Literature with sell sheets, spec sheets, FAQ flyers, and instruction sheets for individual products. And counter displays to help you market these products. These counter displays can be ordered at www.acuitydistributorcenter.com. It may sometimes be necessary to show a building owner just how much energy they can save. This can be accomplished by installing a temporary monitoring system, such as the Data Logger Monitoring System by Sensor Switch. These battery-powered sensors detect and record occupancy and when the room's lights are on, so you can get a graphic representation of when the lights are on but there are no occupants. In other words, wasted energy. The sensors install easily and electronically calibrate to see only the room lights and not residual light in the space, such as daylight shining through a window. You simply select the spaces you want to monitor and place the sensor so it can see the occupants upon entry to the room and the room lights. It is lightweight, mounts easily with command strips. You can simply turn it on and leave it for a couple of weeks, to get some weekend data too, then recover the sensors for data download. The USB port on the data logger downloads the information to the data logger program and presents the information in an easily readable timeline report. White sections indicate that the lights are on. Black sections indicate the space is occupied, and yellow indicates peak hours. In this sample, the report shows that the lights are on approximately 132 hours, but the space is only occupied about 43.5 hours, so the potential savings is about 67% of the energy spent by the lights. This correlates directly to a quantifiable savings in the cost of running the facility. In extreme cases, lights may be left on for days when a space is used infrequently throughout the year. These are excellent examples of low-hanging fruit when it comes to cutting operating costs through energy savings. The Sensor Switch product line from Acuity Controls provides an innovative, high-quality, and cost-effective control solution for nearly every application. Our occupancy sensors and photo control products are easy to install and easy to use. Our passive dual technology with PIR and Microphonics looks and listens for occupants, ensuring reliable detection. Reversible line and load wires make sensor switch products easy to install. Reliable circuit protection tested for over 400,000 switching cycles. Continuous coverage patterns for a breadth of applications meeting your every need. 5-year limited product warranty. Sensor switch products aid in ensuring buildings meet applicable energy codes like Title 24, ASHRAE 90.1, and IECC. Thank you for completing the Sensor Switch Control product overview. You can find more learning opportunities by logging onto our website at www.acuitybrands.com.